Hello viewers, welcome back to the course on scientific computing using MATLAB. So today we will continue with the least square method to find out, maybe today we will do that how we can do the quadratic fit, and then we will also make some MATLAB codes in Octave just to verify that whether we can find out the different polynomials using data or not. So let us start doing this one. So today I will give you that how we can do the least or I can call it quadratic polynomial fit. So suppose we have data, so that data is given to me as points x I and y i's, and I is moving from 1, 2, 3 up to n. So I am taking the n number of points where all xi are distinct and need not be equispaced. So what I want to do, I want to apply the quadratic polynomial fit or the parabola fit. So I can call it parabola also. Parabola curve fit can be written as, so I will call it y, that is equal to, suppose I write is a plus bx plus cx square. So this is the quadratic polynomial I am fitting, and I want to find the value of a, b and c. So this is equation number 1 I can write. Now I can go with the same methods, that suppose I have this, and from here I take this. So now I take the parabola like this one. So suppose I have this parabola, something the quadratic function, and my data points are given to us in this way. So that is the data points. Then I can find the error of this one, from this one, from this one, that we have already discussed in the previous lecture. So then I can define my error as E, function of A, B and C. So this one I can define as A plus Bx plus Cx square minus the yi's I am taking. So this is at the ith points, and then square, and I is moving from 1 to n. Then I can find out the value of this one by, so I want to find the minimum error. So I will define this with the equal to 0, del E by del B equal to 0, and del E by del C equal to 0. So from here I can have the 3 equation. So based on these 3 equation I can find the value of A and B, C, A, B, C, and then I can find out the given parabola. But I can write the direct normal equation also from, so from equation number 1, taking summation over x and y in equation number 1. So I take the summation, and this is yi summation A plus B summation x I plus C summation x I square, and I is moving from 1 to n. So, this is my normal equation, first normal equation. Then I multiply by xi. So, the second one I can write xi yi I from 1 to n is equal to summation a I can take out. So, I 1 to n xi plus b summation I from 1 to n xi square plus c summation I from 1 to n xi cube. So, this I can add a equation number 3. Then multiply one more time also with the x. So, I can have x I from 1 to n xi square yi a summation I from 1 to n xi square, because I multiply by xi again, b summation I from 1 to n xi cube plus c summation I from 1 to n xi power 4. So, this is my equation number 4. So, based on this one, so this is my normal equations. So, based on this normal equation, I can find the system. So, from here the system can be written as, so from here I can write the system as, and this is my A, B, C. So, from first equation I can write, so this is summation n. So, this is n number of values. So, it will be n. So, this is summation xi's and this is summation xi square, and on the right hand side I will get summation yi. Then from the next equation I will get summation xi, summation xi square, summation xi cube, and on the right hand side I will get xi yi. Then I will get summation xi square, summation xi cube and summation xi power 4, and the right hand side this is xi square yi. So, from here I will get this system. So, this system, if you from here you can see that this is equal to this is equal to this, and this is same as this one. So, from here I can say that this matrix is a symmetric matrix. So, based on this one I can take my iterative methods or other methods to solve this system. So, I call it 5. So, now based on this one I can find out the value of ABC, and then we are able to find the parabola of it. So, let us take one example. Suppose I have the given data. So, this is my xi's and this is yi's that is given to me. So, it is minus 3, 0, 2, 4, 3, 1, 1, 3. Now, I take xi's square because I need xi square. So, it will be 9, 0, 4, 16. Xi cube also needed. So, it will be minus 27, 0, 8, 64. Xi raised to power 4 is also needed. So, it will be 81, 0, 16, 256. On the right hand side I need xi yi and xi square yi. So, xi yi will be just multiplying xi. So, it will be minus 9, 0, 2 and 12, and xi square into yi. So, it will be 27, 0, 4 and 48. Now, I just take the summation also. So, based on this one I just take the summation. So, this summation will be, in this case this will be 6 minus 3. So, this will be equal to 3, this is 8, it is 29, it is 45, 353, 5 and then it is 79. So, once I have this data, then I can find the value of ABC and then we should be able to get the curve fitting. So, if I solve this one, then my y will get, so this is the value I will get 0.850519 plus minus 0.192495x plus 0.17846 x square. So, that is my second order polynomial fit for the given data. So, this is the way we can define the polynomial fit for the given data. So, let us do this one with the help of MATLAB code. So, let us start doing the MATLAB code. So, today we will make the codes with the help of Octave. So, I start with the first one, I will start with the Lagrange methods. So, in the Lagrange methods I know that, suppose I have the data. So, that data is given to me. So, this is my x and y. So, that x and y is given to me now. From here I will give the input as x, y. So, this code is I already made for you. So, here I can directly discuss this one. So, I will call it the Lagrange, and in this case the input value is x and y and the output is C and L. So, what is the L? L is the Lagrangian coefficient I know, and C is the coefficient of the polynomial. Now, in this case I will take the length. So, this is, it gives me the length of the x. So, I call it capital N, and small n will be capital N minus 1. So, I call it small n. Now, the L is zeros I take, that is of n cross n. So, now in this case I will define the Lagrangian coefficient polynomials. So, what I want to find? I want to find the Lagrangian coefficient. So, in this case what I will do? I will use two functions, that is, first one is the polynomial. So, let us discuss that what is this meaning for. So, I call it poly. So, let us say define poly 2. So, poly 2 means it gives me the polynomial whose root is 2. So, this is equal to basically x minus 2. So, if I put x minus 2, that is equal to 0. So, in this case I get the polynomial whose roots is 2. Similarly, I can define poly 3 or maybe poly minus 3. Sorry. So, that is the polynomial whose root is minus 3. So, this is I am finding here. So, let us I call it a P, and that is equal to poly 1. I call it another polynomial, that is poly 2. Now, I apply convolution of P and Q. So, this is the convolution and it gives me the, so basically what it is doing, so it is multiplying x minus 2 x minus 1. So, this is I am doing. So, now from here I can see that this will be x square. So, the coefficient of x square is 1. Now x minus 2 and minus 1. So, minus 3x. So, this is minus 3 and in the end minus 1 into 2 it is 2. So, it gives me the coefficients of the quadratic having the coefficient 1, minus 3 and 2. So, that is the function convolution. I can write that help. So, from here I can just delete this one and I can write help so it gives you that the documentation of the function. So when a and b are the coefficient vector of two polynomial, convolution represent the coefficient vector of the product polynomial. So convolution of a and b. So this is the way we can define. So let us go to the. So now in this case what I do, I will define the for loop. K is from 1 to n. V I just take as a 1. Now for j is equal to 1 to n, when k is not equal to j, I will apply this function. So what is this meaning for? First we will find out poly xj, because I know that. So after doing this one, I just take the next. So in the Lagrange polynomial, octave chord. So I know that in the Lagrange polynomial, I have the polynomial, suppose I have px. So in this case I know that suppose I have the point x0, x1, x2, y0, y1, y2. So I will get x minus x1, x minus x2, x0 minus x1 and x0 minus x2, and here I will get y0. Next it will be x minus x0, x1 minus x0, x1 minus x2, y1 plus x minus x0, x minus x1, x2 minus x0 and x2 minus x1, and this is y2. So this is I am going to find out. So from here you can see that this here I will put the points. So this is a constant value, but here you can say that this is a polynomial whose root is x1 multiplied with a polynomial whose root is x2. So I am using this one here. I am defining the polynomial whose root is xj, right, when k is not equal to j, and I am multiplying this one with the v. I started with the v is equal to 1 divided by xk minus xj. Okay. So I am doing this one. So this is a multiplication I am doing divided by xj minus xk. So that product is also I am taking. So with the help of this one I am able to find all these Lagrangian coefficients, Lagrangian polynomials, whatever we are defining. So what I am going to do, I am going to find out what is the value of this one, what is the value of this one, and what is the value of this one. And this one I can do for the all values of the data that is given to me. So this is I can define from here, and based on this one, so based on this one first I will do the convolution and then I multiply by all these factors, whatever k is not equal to j, other factors I will take, and I will all this will be saved in the value of v. So this v is I am going to have. So now this if loop is over and then this for loop is over, and then I will what I do, I will write this value of v as a. So here I have defined L as a 0 and n, it means I have defined this as a matrix. So in the matrix if I take Lk and all the columns, so I will get the value of v. So I am saving this value in the kth row. So, this you can see that k is equal to 1. So, the first value will be saved in the first row, then the second row, then the third row, then the fourth row. So, I have total n number of the Lagrangian fundamental polynomial, and that the value of this will be saved in the L function, L matrix. So, once I done this one, then I can find the coefficient of the Lagrangian interpolating polynomial, that is y into L. So, what is y into L? So, this is y into L. So, this is my y and this is my L. So, I am taking this as a L and this is my y. Okay. So, from here I just take the multiplication and then my polynomial will come. So, let us take one example of this one. So, let us take this script file. So, I will take first with the quadratic polynomial. So, let us this one I am doing, and for the Lagrange I will do this one L, this one. So, generally I make the script files so that I should be able to this one. So, I have done the comment. So, I have the value of x and this y, and then I want to find this one. So, let us run this one. So, this is the answer I am going to get. Now, the first because I am printing this one for the whole loop. So, if I go for the first one, so this is the values I am getting 0.33 minus 1.3 and 1. So, this is the coefficients of the first Lagrangian polynomial, that fundamental polynomial. This is the second one and this is the third one. So, I know that I will get only 3 values. So, this is if you see from here, the first one is saved here because this is a quadratic. So, I need for the quadratic I have 3 coefficients. So, that coefficient is there, then this and then this. Okay. So, based on this one, so that is the value I am getting, and then this is the C. So, that is the coefficients of the corresponding polynomial, the Lagrangian polynomial. So, based on this one I will get the value of 8, minus 6 and 1. So, if you remember, then in the previous examples we have solved this one. So, I have solved this one in the previous lectures, and if you see, then I will got this value. So, I will get this polynomial as 1 by 3 x minus 1 x minus 3, because I have the data 0, 1 and 3, 1, 3 and 55. So, I got this one. So, from here you can just see it will be equal to 1 by 3 x square minus, so it is x square minus x and minus 3. So, minus 4x plus 3. So, it is 1 by 3 x square minus 4 by 3 x plus 1. So, the coefficient is 0.33 x square minus 1.3 x plus 1. So, this is the coefficient I am getting. The second one is from here I am getting minus 1 by 2 x minus 0 and x minus 3. So, from here it is half x square minus 3x. So, the coefficient is from here you can see that it is minus 0.5 and 1.5. So, minus 0.5 and 1.5 and other value 0. So, similarly I get this one. So, based on this one, if I find out the Lagrangian polynomial, So, the finally I get this data. So, the final my P2x, the Lagrangian polynomial is coming 8x square minus 6x plus 1, and that is the answer, and from here also I am getting this answer. So, that is the coefficients 8x square minus 6x plus 1. So, using this one I can find the corresponding Lagrangian polynomial for any type of data. So, here we have taken just 3 data points, but we can have as many data points as we wish, and I can run the same code for that type of data. So, this is already there. Now, the same thing I have done so let us again try to find out for another type of data. So, let us take cubic polynomial. So, let us I take this data. So, this data is the 4 points I have taken, and I run this one. So, I get this value. So, this is the 4 by 4 matrix I am going to have. So, this is the coefficient of the first fundamental Lagrangian polynomial, then second, the third and fourth, and the coefficient this one. So, it means that 0.09 x cube minus 0.56 x square plus 0.0135 x and plus 1. So, that is the corresponding cubic Lagrangian interpolating polynomial passing through the given points. So, this is my given point, x is this one. So, it is a capital X and this is a capital Y. So, that is the points I have chosen and passing through these points. So, the same way I can define with the another data. So, this is the corresponding simple data I have chosen. So, in this case this is the corresponding fundamental, the coefficient of the fundamental Lagrangian polynomial, that is a cubic here, and in the end we will get this value. So, it means that this is x cube minus x square plus 3x plus 8. So, that is the polynomial. So, after that I can see that what is my x and what is my y. So, based on this x and y, this is my cubic polynomial, Lagrangian polynomial passing through these points. So, I am defining this with the cubic function. So, let me stop today here. So, today we have started with the parabolic fit, and then we have done one example, and then we have started with the MATLAB code or the Octave code for doing such type of problems numerically with the help of MATLAB. So, we will continue with this one. Thanks for watching. Thanks very much.